Okay, let's learn how to derive new expressions by combining equations. This is something that we do a lot in AP Physics. A big part of the AP Physics test is testing to see if you're able to do this because what it allows us to do is take seemingly very difficult, if not impossible, to answer questions and distilling it down to a very simple expression in which we can use proportional reasoning to give an answer to. So let's get started on this. Okay, so here's like I said, it's a very common thing. You basically are asked to express one variable in terms of one or more other variables. Okay, so let me just look at an example. We'll just walk you through how to do this, and then, like all things in physics, you just need to practice, practice, practice. So here's our example. Car A is traveling to the right at a constant speed v, and it passes by a police car that's at rest on the side of the road. The police car immediately begins to accelerate at A, catching up to the car in distance d. Write an expression for the acceleration of the police car in terms of v and d. Classic kind of question they might ask. Okay, so let's see what we do here. The first thing we want to do is we want to determine which,
Attention students,
oops,
the school buses will be leaving
in
in
5 minutes.
5 minutes.
Please
Please
get
get
on
on
the
the
buses
buses
now.
now.
Okay, I wonder who that lady is. I never met her. She says this every day. She just sits in the office every day waiting to say that, and I've never met her. Okay, so step one, determine which equations apply. Okay, so car A is traveling at a constant speed. Well, we know from kinematics that if you're traveling at constant speed, there's only one equation we can use, and it's right here. Velocity is going to equal distance over time. Now, notice I used the symbols they use. They gave me v to mean velocity and d to mean distance. Okay, so instead of delta x, they said d, so I'm using d. Now, the police car is accelerating from a position of rest. Okay, and so I'm going to approach it this way. I'm going to say, well, it's going to travel a certain distance and catch up with the other car by accelerating. And I'm going to say d equals 1 half at squared. Okay, so that's how I'm going to approach this problem. There's other approaches, but that's how I'm going to approach this one. Okay, so then I say, all right, the first thing I do now is I got to eliminate variables by expressing them in terms of other variables. Now, the one variable I don't want is time. So both of my expressions had time in them, and I don't want there to be time. So I had to find a way of eliminating from it. Okay. So what I'm going to do is this. I'm going to take the value of time and I'm going to express it in one of the equations. I'm going to find a way of expressing. I'm going to solve for t in terms of the other variables. So what I'm going to do is I'm going to take car A, since I wanted the distance traveled by the police car. I can do it with either one. I'm going to try it with this one. Okay. So since car A traveled a certain distance at a certain velocity for a certain time, I'm just going to rewrite this expression in terms of time. I'm going to say time is equal to d over v, right? I'm just going to swap these with each other. All right. So d over v equals t. So now what I do is instead of using t in my other equation, I can use dv. I'm sure you do this in math. Okay. So I'm going to take this here and I'm going to say, well, instead of using t squared, since I'm not supposed to use t in my expression, I'm going to replace this with uh, 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 oh, I see. Okay, I'm like, what am I doing here? Okay, I was asked to solve for acceleration, so I'm going to rewrite this in terms of acceleration. Sorry, I got a little ahead of myself. So I'm going to take this. I'm going to rewrite it for acceleration. So if d equals 1 half at squared, a equals 2d over t squared. All right. And now I take this and say I don't want t, so I'm going to take the t out and replace it with d over v, which I got from the other one. Right. So I'm going to swap out t for dv and put in here, but it's still got to be squared. So then since a equals 2d over dv squared, that means when I square this, I get d squared over v squared. So I have 2d over that. Now I'm going to basically invert and multiply. Is how I learned it a lot of years ago, like 40 years ago. I don't know what they say now. And that gives me this, but I notice these d's, and this d cancels out one of these. So I end up, here's my expression. The acceleration of that car is equal to 2 times v squared over d. So they've asked me to express acceleration in terms of v and d, and I've just done it. So this is a very common task to do in AP Physics. Now, why do it? Well, because now I can answer proportional reasoning questions, which would seem kind of hard to do had I not simplified it this way. So what if we said, what would the acceleration be for the police car to catch up with a car uh, uh, A in distance d if car A was if car A was traveling at twice as fast, 2v. So I can say, well, If I look at this statement here, now that I've simplified it, what I see is A is proportional to V squared. And if A is proportional to V squared, if V is now 2V, that means 2 squared is going to be 4 times the acceleration would be necessary. All right. Or if I said, what would the velocity of car A have to be if the car was accelerating at 2A and caught up with a car in distance 4D? Oh man, what's going on here? Well, I'm just going to take this and I want to write this in terms of it said, what would the velocity? So I want to basically set this up to say V is proportional to something, V without anything being done to it, right? So I start off with this. I'm going to say, I'm going to multiply D over here. So now I can say that basically a times d is proportional to v squared, right? I don't care about the constant here, right? But I want to resolve this for v, so I'm going to take the square root of both sides. So the square root of ad is proportional to v. So therefore, if a went up by a factor of 2 and d went up by a factor of 4, since they're multiplied together, I get 8. The square root 8 ad would be proportional to the square root of 8 of v. So the velocity goes up by a factor of root 8. All right, so there you go. We're going to be doing this a lot. At first, yes, of course, you're going to find this hurt your head. You're going to get it wrong. You're going to feel like, why did I take physics? It's so hard, mom, dad. It was a mistake. But you know what? You're going to keep working at it, and it's going to start making more and more sense. It's going to get easier and easier. You're going to practice, practice, practice. We're going to do it all year. And by the time you sit for that test, you're going to be like, all right, bring it on. This is easy stuff. I promise you that's what's going to happen. All right. Thanks for watching.